So the goal of every inequality is to get the variable by itself on one side, just like equations. Just like equations, that's the goal. Remember Ronaldo. But there's only one thing that we got to remember about inequalities that's a little bit different. One slight difference, slightly. Whenever you multiply or divide by a negative number, the inequality symbol changes direction. That's the only thing you got to remember. But everything else is exactly the same way you handle equations. You get a variable by itself on one side. Go ahead and copy that down. All right. Example 1. Solve for x. Let's go. 10 is less than or equal to, let's say, 2x plus 4. 10 is less than or equal to 2x plus 4. All right. What's the goal? Well, Ronaldo, remember Ronaldo's picture a couple weeks ago? The goal, just like an equation, the goal is to get the variable by itself on one side. Right now, the variable's on the right side of the inequality symbol. Let's get it by itself. We'll get rid of the 4, and then get rid of the 2. Remember, we get rid of the numbers farther from the variable first. Here we go. So, oops. What's the opposite of adding 4? Whatever you do to one side, do to the other. Remember, like a balance. Just do it. This is all old hat. This is old news. We know this. We could do this in our sleep at this point, right? Let me bring down the inequality symbol. Watch this. 2x. This is gone. But notice how I'm bringing down an inequality symbol now, not an equal sign. But everything stays the same. Watch this. 10 minus 4 is 6. We're good to go. Watch this now. Let's divide by 2. X then is greater than or equal to 3. Look how x is described. X is by itself. Just think about what this means here. X is greater than, look at the mouth once it eats the x. The x is greater than or equal to 3 means any number that's bigger than or equal to 3 will satisfy this inequality up here. Remember, solutions satisfy? That's been part of our quiz. I've been asking that every quiz. What's the solution? It's a number that satisfies an equation. Well, look at this inequality. What number will satisfy this inequality? Well, look at any number x that's bigger than or equal to 3. How many numbers in the universe are bigger than or equal to 3? Infinite. Go from 3 onward that way on the number line. It's infinity. It doesn't stop. So you literally have an infinite amount of solutions. So watch this. You can write this right here. The solution, I should write solutions, are any number. I'm going to use the number sign, like hashtag. Any hashtag number greater than or equal to 3. How many are there? Perez said it perfect. There's an infinite amount of them. 3.1, 3.2, 3.3, 3.4. Those are all bigger than 3. If I take any one of those numbers and put them into the original inequality, it would satisfy. Let's test it out. Adiola, what's your favorite number? Is it 4? Is 4 bigger than 3? Yes. So let's see if Adiola's number fits, if it satisfies the inequality. I'm going to put the inequality in blue, even though the Dodgers lost. Watch this. I'm going to use Dodger blue here. I'm going to test now. Watch. On your notes, let's put test the number 4. Notice, I'm just picking any number. It's Adiola's favorite number. It's bigger. I'm testing any number that's bigger than 3 and see if it actually satisfies the original inequality. It's the one that we started off with right here. So let me rewrite this inequality down here in blue. I got 10 greater than or equal to 2x plus 4. Let's see if 4 satisfies. Okay? Wherever I see x now, I'll replace it with 4. Rodriguez, stay with me. Watch this. 10 greater than or equal to 2 times 4 plus 4. Is this true? Let's see. Let's keep going. Let's see if it's true. Let's see if it satisfies. Let's see if it results in a true statement. That's what satisfies means. Watch. 10, is that greater or equal to 8 plus 4? Is 10 greater than or equal to 12? Is that true? So something went wrong, huh? Let's see. Let's look at our work. I put the sign wrong. Thank you for good looking out. So all this should have been the other way around. That's good you guys saw that. So it's this way. Now it's true though, huh? 12 definitely is greater than 10. So it satisfies. So it's true. Satisfies. Do you think 3 will work? Argument, Garcia. Give me an argument for why do you think 3 will work. You're right. Give me an argument, though. Right. Look at x is not only bigger than 3. Numbers that are bigger than 3 are like Adiola's favorite number. You picked 4. But also equal to 3. X can actually equal 3 and it'll satisfy. Let me test it real quick. Let me test 3. You don't have to test with me. You can let me do the work. If you want, it's up to you though. Here we go. Let me see if 3 will work. 10 equals or less than equal 2 times 3 plus 4. Let's see if this is true. Is 10 less than or equal to 6 plus 4? Is 10 less than or equal to 10? Yes, that's true. Look at 10 is equal to 10. That's a true statement. It satisfies. All right. Believe it or not, I'm only going to do one example today. Actually, you know what? I forgot to graph. Same example. Let's go ahead and put graph now. Watch this. Let's graph the solution. Let's graph it. How do we graph x is greater or equal to 3? How do we graph the solution? Watch this. We're going to draw a number line. So on your notes, put a graph. Now, we're still on example 1. We solved for x, that's x right here, and then we wrote it out, what the solutions meant. Then we tested some solutions, and now we're going to graph it. This is all one example. Okay, here we go. Let's graph x is greater or equal to 3. Let's graph it. Watch this. Let me put some numbers and make sure 3 is, I'm just making a number line. I'm going to put some numbers here. How about 1, 2, and 3? All right. What I'm going to start doing now is I'm going to shade the number line that represents the solutions. I'm going to shade the number line that has all the solutions like Adiola's favorite number and every number that's bigger than 3. Remember Perez said it's an infinite amount. So look what I'm going to do. I'm going to shade that part. So I'm going to shade everything bigger than 3. Look at, shade that with me. I'll even shade the arrow because that means it's going on infinitely. And x can actually be 3, so I'm going to shade 3 too. I'm going to put a dot, a closed dot on 3. So this means x can be any number that's 3 or bigger. And this, I shade all the bigger parts, the bigger numbers. So there's your graph. Go ahead and copy that down.